API Authentication, explained in just 5 minutes. Imagine you've created a web application for a library of books. If a user wants to fetch a list of all the books available in the library, they'd send a GET request to a specific endpoint. The server receives this request and prepares to send back the book data. But how do we ensure that only authorized users can securely access this information? How do we verify who is making the request and determine if they have proper access? This is where API authentication comes into play. It's the process of verifying every request to ensure that only trusted users or systems can access the API. Without authentication, anyone with access to the API URL could make requests, leading to data leaks, breaches, or unauthorized use of services. So let's explore some common methods of API authentication, starting with API Key Authentication. When a user or application registers to access an API, the server generates a unique API key. Think of this key as a password that identifies the user or system making the requests. The client includes the API key in the request headers or as a query parameter. When the server receives the request, it cross-references the provided API key with its database of authorized keys to confirm the client's identity. If the key is valid and the client is authorized, the server processes the request and sends back the requested data. Otherwise, it denies the access, returning an error response like 401 unauthorized. An advantage of API Key Authentication is that it is straightforward to implement, making it ideal for basic authentication scenarios. Next, we have HTTP Basic Authentication, one of the simplest methods. Here, the client sends a request to the API server, typically to retrieve or send data. And in return, the client requests for a username and password for authentication. The client includes an authorization header in the HTTP request, containing the username and password encoded in base64. The server decodes the base64 string to extract the original credentials and verifies them against a database or predefined user list. If valid, the server responds with the requested data. If invalid, the server returns an error, such as 401 unauthorized. While easy to implement, this method is insecure. Credentials are sent with every request and not encrypted by default, making them susceptible to interception. The next popular method is JWT, JSON Web Token Authentication. So here's how it works. You have the client that sends a login request to the server with the user's credentials. Then the server validates the credentials and, if correct, generates a JSON Web Token. This token contains data such as the user's ID, roles, and expiration time. The server sends the JWT back to the client, typically in the response body. The client stores the token for future use. When accessing a protected resource, the client includes the JWT in the authorization header as a bearer token. Upon receiving the request, the server validates the JWT. If valid, the server processes the request. If the token is invalid or expired, the server denies the access. JWT authentication is popular because it allows servers to issue tokens that clients can reuse. These tokens are signed, preventing tampering, and they eliminate the need for storing session data on the server. And finally, the most widely used method is OAuth, Open Authorization. OAuth is a protocol that allows third-party applications to access a user's resources without exposing their credentials. Here's an overview. The client application redirects users to an authorization server, passing parameters like client ID, redirect URI, response type, and scope. The user grants or denies the application's permission to access their resources. If access is granted, the authorization server sends an authorization code to the client via the redirect URI. The client exchanges the code for an access token by sending a POST request to the authorization server's token endpoint, including parameters like the authorization code, client ID, client secret, and redirect URI. The client uses this token in the authorization header of subsequent API requests. The resource server validates the token and processes the request if the token is valid. What makes OAuth highly advantageous is that it is highly secure, making it suitable for complex authentication scenarios involving third-party integrations. The API authentication process provides many crucial features and benefits. For example, it ensures security by verifying client identities to protect sensitive data and resources. It also enables controlled access by implementing permissions and roles for different levels of access. It also monitors usage by tracking API usage patterns, detecting anomalies, and ensuring fair use. It can also apply rate limits to prevent abuse by limiting the number of requests per client, protecting against DOS attacks, and ensuring system stability. These features enable you to have an optimized API security and performance, ensuring only trusted users and systems interact with your applications. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and leave a comment below. Thanks for watching, and I'll catch you in the next one. Bye for now.